Okay, actually, I want that other one. I just recorded this lesson and it only recorded half because the platform I was using will only let me record little tiny bits at a time. Anyway, it wouldn't be Miss Brown if you didn't hear my little story. So there it is. We're going to do 4.1 checkup, and I'll do a few problems and then you'll have some to do on your own. But before we do, we should go over the notes. And as you probably just saw, hold on, this is in your Google Classroom down at the very bottom under Unit 4 notes, which I'll add to throughout the unit. But for now, we've got notes on polygons. Some of this we've learned, we discovered the last time we were together, but here we go. A polygon's definition is a two-dimensional enclosed figure with straight edges and no intersecting lines. So a circle is not a polygon because it doesn't have straight edges. It's got to be enclosed. If any part of this little guy here was open, it would not be a polygon, but this is a polygon. There's something called a regular polygon. Regular means it has equal sides and it has equal angles. All the sides are equal to each other. All the angles are equal. That's going to be really important when we get down to finding one angle inside or outside. We've also got something called convex and concave. I have to have a trick to remember which one's which. Concave to me is a polygon where some sort of a cave has been created, like this right here. This little kind of inlet place is a cave to me. So that makes this a concave polygon. But the definition, convex, means all the interior angles are less than 180 degrees. They're less than a straight line, which makes it kind of all, I want to say enclosed, but they're all enclosed. It's all inside. I'm not explaining it well. My brain knows what I'm trying to say, but no one else does. But again, concave has this situation where this angle right here, that is greater than 180 degrees. It goes all the way to straight and then some more. And another way to tell is if you connected these two vertices, the line that connects them would be outside the polygon. If the line that connects the vertices is outside the polygon, then it is concave. We very often work with convex, but we'll see some concaves in there. We discovered last time we were together the sum of the interior angles of all polygons is 180 degrees times n minus 2. I think we wrote it the other way around, n minus 2 times 180. It doesn't matter with multiplication, the order doesn't matter. But n is the number of sides of that polygon. If I wanted to find one interior angle, I could do that if it was a regular polygon. I would take the sum of all those interior angles and divide by the number of sides, which makes sense because all of the sides are equal and all of the angles are equal. So if I divide by that number, we're going to get equal measurements for each angle. The sum of the exterior angles of a polygon is super simple because all of them is 360. There's no formula, there's no fancy anything. It's just they are 360 degrees when you add up all the outside angles. I'm going to show you what the outside angles mean or what they look like in a little bit. And again, if I wanted to find one exterior, it has to be regular to do it this way. I could take 360, the sum of all of them, and divide by the number of angles. And the number of angles matches the number of sides. It's the same thing. So n is also the number of angles. Okay, so those some notes. You need to write these in your own handwriting, some neat organized place where you have all of your notes. Let's then work on the 4.1 checkup. And again, they give us that formula. When I recorded the lesson a minute ago, I wrote right on the worksheet, and now all the answers are here. So this is fun. They gave us the formula here. We discovered it the other day. It's also in our notes. The directions say find the sum of the interior angles of a regular polygon. Well, if it's the sum of the interior, it doesn't matter if it's regular or not. But they threw that in there. I put the number of sides for each of these. You could always look them up. A pentagon, you hopefully know, has 5 sides. If not, now you do. A nonagon has 9 sides, and a 13gon has 13 sides. They also gave you the figure, all the figures for those three. So you could add up the sides, right? It doesn't matter that this one's cut off. They gave you 13 sides right here. So we're going to solve the pentagon, which has 5 sides. Since I already wrote on the worksheet, I'm going to switch to the whiteboard. And again, the n value is 5. The formula is n minus 2 times 180 degrees. So we plug in the n value. 5 minus 2 is 180 degrees. And we get 3 times 180 degrees. And we could use a calculator, and we get 540 degrees. So the sum of the interior angles for all pentagons, if I add up all those inside angles, I'm going to get 540 degrees. Whether it's regular or not, it's kind of funny that they put regular. For this section, it doesn't matter. For the next section, it does matter. I'm going to let you try 2 and 3. The next section asks you, so fancy here with my high-tech stuff. For 4 through 6, it says find the measure of each exterior angle. Well, that means I'm really going to find one of them, but they're all the same because they are regular. And I can do this method that we saw in our notes if it's regular. And now we're talking about exterior angles. So, time out. Let's get the next page. And again, I've written on the worksheet because I already recorded this and it cut me off. Number 4 says a triangle. I'm pretty sure you know how many sides are in a triangle. So we're going to do number 5, and it says a regular heptagon. Oh, I think it's a good thing I'm reading this because I read it as hexagon. It's heptagon, which is also like septagon, and that has 7 sides. Oops, I cut off. Zoom out. Hepta is 7. Septa is 7. If I'm not mistaken, one of these is Greek and one of them is Latin. But there's 7 sides. Heptagon. So I did not do it right. All right, I'll fix that on my answer key. So the n value is 7. So if we go to our notes, time out, let's go to our notes. I think it's a good idea to see where I'm getting this information. We're finding one exterior angle. One exterior angle, and it is regular. So I'm going to take 360 and divide by n. So let's do it. 360 and divide by n. Let's just go to the calculator and see what the calculator says. That's our next problem soon. 360 divided by 7. Oh, we get about. Let's round this. Can I fit that all? Sure can. I get 51, about 51, because I'm not going to, it's rounded somewhere in there. 4, let's just say 3. Because if I'm going to round to this place, this number, I've got to look at the number to the right. If that number is 5 or more, we add 1 here. So it's about 51.43 degrees. All right, I'm pausing. I don't need to because it's a recording. Oh, by the way, I meant to talk about an exterior angle, since that's what we found just here. Let's say we've got some figure. I'll just draw a portion of it. Good gracious, terrible drawing. Let's do a little better than that. Okay, so let's say you just see the top of some, this is a hexagon. It's so bad. And if I extended this off, extend this line right here to go straight. This angle right here is that exterior angle they're talking about. Again, if I extended this one out here, it would be this angle that we're talking about. That's the exterior angle. We have to kind of extend one of the side lengths to see the exterior angle. All right, number 7. Let me clean things up around here. And I'm going to do number 7 next. I'll let you do 4 and 6, similar to what I just did with 5. Same concept. Number 7 says, given the measure of each exterior angle of a regular polygon, determine how many sides the polygon has. So we're looking for n. A minute ago, in the last problem, we did 360 and we divided by n, and that got us 1 exterior angle. Okay? Well, this time, they give us 1 exterior angle. And again, this is for a regular polygon. So I'm going to use the same method. I'm going to take 360 divided by n. I don't know what n is, but the exterior angle they give us for number 7 is 30 degrees. Before, we knew what n was. We plugged in 7. And I already erased it. We got 51 some degrees about. And now we have the angle measurement for 1 exterior. We're looking for the number of sides. Here's what I suggest. Whenever you have a fraction equal to something that's not a fraction, you could just make it a fraction and cross multiply. So this times the denominator, this numerator times that denominator. That'll give us 30 times n is equal to 360 times 1. And then we'll divide out the 30 on both sides. And that becomes a 1, leaving me with n. We could divide by 10 and make it easy on ourselves. And 3 goes into 36 12 times. So it's a 12-sided polygon. I think it's a dodecagon. I'd have to look it up. 12-sided. All right, I'll let you do number 8, same method. Number 9 and 10 are similar. I'm going to do 10. I think it's a little weird, to be honest, but let's just go with it. Let's figure out what they want from us. Number 10 says, each exterior angle of a regular polygon is about 21.18 degrees. So it's not exactly that, but it's close. So when they did their calculation, like up here, they had some approximation. And that's each exterior angle. They want to know what the sum of the interior angles is. Well, let's remember the sum of the interiors is 180 times n minus 2, right? That's the sum of the interiors. So I need to figure out what n is. So again, we're going to do the same thing we did up here. We have an exterior angle, just like we had up here. We'll use this method to figure out what n is, and then we can plug in the n value. Let's do it. So we have 360 over n equals 21.18 over 1. It doesn't really equal it, it's about that. It's not exactly that. Somewhere along the way they rounded. Cross multiply, and now my son is going to drum. That's perfect. And I messed up there again because it's not exactly, it's about. And then we'll divide out the 21.18. Divide out 21.18. That's it. Hopefully the drumming isn't bothering you. And let's go to our calculator. We're not done now. After this, let's see. We get 360 divided by 21.18 is this. So what we just found was the n value, the number of sides. How can the number of sides be part of a side? It's like 16 and almost 17 sides. The polygon has almost 17 sides. That doesn't even make sense, right? But remember, this 21.18 was about the measure of an exterior angle. It was close. It wasn't exactly. That's pretty darn close to 17. So I'm going to say this has to be a 17-sided figure because it can't be part of a side. It's not 16. This is way closer to 17 than it is to 16. So it's got to be a 17-sided figure. And we're not done though. Remember, the goal was let's find n and plug it in. So we've got n. Let's take that and plug it in. We have our 180 times 17 sides. 180 times 15. And let's go to the calculator. Oops, clear it out. Calculator. A little extra light there. 180 times 15. And we get 27. What is it we found? We found the sum of the interior angles of a 17-sided polygon. All right, good stuff. That's that for 4.1. You're all ready for the quiz. Maybe a little studying first.